Here we have a rational equation, and we'd like to solve it. The method that we're going to use to solve this is we're going to find a least common denominator. We're then going to put everybody over that least common denominator, mush together the left-hand side, and then set our numerators equal to each other. Well, if you're not careful about this, you might say to yourself, oh, least common denominator, gosh, I need an x squared minus 9. This looks nothing like this, so I need a factor of x plus 3. And I need a factor of x minus 3. Very, very complicated expression. So what you need to remember is when looking at rational equations, the first thing that you need to do is factor all the denominators. X squared minus 9 turns out can be factored as x plus 3 times x minus 3. Interesting. Let's see if that helps us out. Well, let's see. My least common denominator, I need at least a factor of x plus 3 times x minus 3. Do I need to add anything more here? No, I already have a factor of x plus 3. In fact, how many times does this go into this? X minus 3 times. That'll work. I need a factor of x minus 3. I already have it, so I don't need another one. In fact, this divides into this. How many times? X plus 3 times. So this is our least common denominator. So we have 1 over x plus 3 times x minus 3 plus, let's see, we need an x minus 3 over x minus 3. Let me do it on the right-hand side. And the right-hand side of the entire equation needs an x plus 3 times an x plus 3. So let's see. We now have the same denominator on both sides. Let's start mushing things together. So this becomes 1 plus 2 times x minus 3 over x plus 3 times x minus 3 equals x plus 3 over x minus 3 times x plus 3. At this point, students get tempted to cancel things. You don't want to cancel at this point. First off, this canceling would be illegal. This would be a surgery without anesthesia. And if you've never heard of that expression, feel free to take a look at it in my misconceptions section of the site. It would be legal to cancel these guys out, but you'd be back where you started. It's like 1 step forward, 2 steps back. Don't want to do that. We want to move forward. What do we want to do? We want to set the numerators equal to each other. So we're going to set 1 plus 2 times x minus 3 equal to x plus 3. We now have a linear equation that we need to solve. So we get 1 plus 2x minus 6 equals x plus 3. Looks like I can subtract x from both sides to get rid of the x on the right. 1 minus 6 is minus 5, so I'm going to add 5 to both sides. On the left-hand side, 2x minus x is just x, left with an x. On the right-hand side, 5 plus 3 is 8. So we just solved this linear equation. Just solved the linear equation. But I'm actually interested in solving the original equation. And we have to be very careful with rational equations because you can't divide by 0. So we need to make sure that with this 8, we didn't do that. 8 squared minus 9 isn't 0. Last time I checked, 8 plus 3 isn't 0. Neither is 8 minus 3. So looks like we have our solution of x equals 8. To recap how we solved this, we made sure that we factored first. After factoring, we saw the LCD was x plus 3 times x minus 3. We gave each piece what it needed. This guy didn't need anything. This needed an x minus 3. This needed an x plus 3. Now that we were dealing with apples and apples, same denominator, we just mushed together the numerators. Set the numerators equal. Found our solution. And then double checked it in the original equation.